Good morning, I am Dr. Huang. Today, I am going to teach you how to use dimensional analysis to do conversions. Dimensional analysis heavily rely on the use of conversion factors. So, let's go over the properties of conversion factors first. The first property of conversion factor is a conversion factor is always a fraction. 1 pound over 16 ounces is not a conversion factor because it is not a fraction. 1 pound over 16 ounces is a conversion factor because it is a fraction. Number 2, both the numerator and the denominator of a conversion factor always have units. 1 pound over 16 ounces is a conversion factor because it has units on numerator and unit on denominator. 1 over 16 ounces, 1 pound over 16, 1 over 16 are not conversion factors. 1 over 16 ounces and 1 pound over 16 only has 1 unit. So they are not conversion factors. 1 over 16 do not have any units. So it's not a conversion factor. Number 3, conversion factors always come in pairs. Let's call them twin conversion factors for the sake of clarity. 1 pound over 16 ounces is a conversion factor. If you flip the numerator and denominator, you get its twin conversion factor. 1 pound, 16 ounces over 1 pound, and 1 pound over 16 ounces are twin conversion factors. Number 4, only one of the twin conversion factors can be used in each conversion calculation, but it can be used more than once. If 16 ounces over 1 pound is used in a calculation, and 1 pound over 16 ounces cannot be used in the same calculation, but you can use either 16 ounces over 1 pound or 1 pound over 16 ounces more than once in the same calculation. The first method to find conversion factors is from an explicit equal relationship. Generally, they are provided directly by the problem you are trying to solve. When I say an explicit equal relationship, what I mean is I say an equal sign. Let's take a look at this one. I'm not going to read through the whole paragraph. It's pretty long. What I'm looking at is I'm looking for equal sign. So 1 pound equal to 453.6 grams. When I say equal sign, I'm quite excited. 1 pound over 453.6 grams. And then I flip the numerator and the denominator. I get another conversion factor. 453.6 grams over 1 pound. And then I find another equal sign. Then I get another 2 conversion factors. 1 pound over 16 ounces or 16 ounces over 1 pound. The second method to find conversion factors is from an implicit relationship. Generally, they're provided by the problem you're trying to solve, but you don't say an equal sign. Let's look at the example. Look at the first example. The density of water is 0.998 gram / milliliter. When I say slash, from mathematics, this is equivalent to 0.998 gram over 1 milliliter. Obviously, this is a fraction. So we get another conversion factor. 1 milliliter over 0.99 gram. Okay, to summarize this method, if you say a slash, generally you get 2 conversion factors. Let's look at another example and say how we can get more conversion factors. And this time, we have to go through the whole paragraph and find all possible conversion factors because we are not looking for equal signs. A frog has a mass of 4.60 ounces and can catch flies at an average rate of 2.0 flies every 3.5 seconds. Then this we can get two conversion factors. 2.0 flies over 3.5 seconds or 3.5 seconds over 2.0 flies. When we continue to read, if every fly has a mass of 2.5 milligram, this means one fly has a mass of 2.5 milligram. This indicates another two conversion factors. One fly, 2.5 milligram, or 2.5 milligram over one fly. How long in hours will it take before the frog has caught enough flies to increase its mass to 0.35 gram? We don't find any implicit relationship to give us conversion factors. In answering this question, use the fact that 1 pound equal to and 1 pound equal to 16 ounces. These two can give us conversion factors, but they are not implicit. So I'm not going to write this out here. Okay, the third method to find conversion factors is most challenging because it relies on what you remember or what you have learned from class. Such as in class, we learn metric prefix in chapter 1. In the future chapters, we are going to learn formula weight or balanced chemical equations. We can get conversion factors from them. But the problem is when you learn more and more relationships, you don't know which one you need. So this will rely on what the problem is. So let's look at the example. The volume of a container is 10.6 meter cube. What is the volume of a container in centimeter cube? When we read this problem, we are looking at a conversion between meter cube to centimeter cube. We do not have any explicit relationships. We also cannot find implicit ones. Then we need to look up our memory, say which one can possibly help us. We get meter cube. We have centimeter cube. So by looking at them, one of them we have prefix C. So this reminds us we probably need a relationship from prefix. If you remember, C equal to 10 to the negative 2. Because we are looking for centimeter, not C, so you add m on the left and m on the right. And then we can get two conversion factors from here. 1 centimeter over 10 to the negative 2 meters, or 10 to the negative 2 meters over 1 centimeter.